Notre Dame twice.
Okay, so we did cartography, which is the study of making maps, and we made a scale map, a 3D to scale map of our classroom, which is this room, and to just get where like everything is. This table is this table, and usually this table is up against this one. So this table would be table 3. We measured the length, width, and height of all these things, and then we divided by 15 to get our scale. So we divided all the sides by 15, and so that's how we got this just scale map of the classroom. Oh, sorry. This is Forrest. He was in cartography. This is Autumn.
And I'm Sam.
And I'm Willow. And James was also in cartography, but he was not here.
So, no, that's it. Sammy's home. When we were making the maps, we had to measure all the shelves, and as she said, divide them by 3. Then 15. And then we had to, so we made a 2D map at first, and then we decided we wanted to make it 3D. So we had to measure everything's height, and we had to come up with how to make them stand up. And we used the method of, there's little tabs under all of the squares, and that are fold out at the bottom and are taped so that they don't come off as easy. And this is the door that I made. It's just because so I had to measure it, and Forrest did the computer, and it's just a scale. Yeah, Mr. Chris's laptop, and Willow, she came up with the idea how to make a chair. So we had a lot of fun.
Your doorknob is to scale, so everything but the computer is to scale of.
And some of the chairs aren't exactly to scale. They're mostly, but my doorknob is to scale.
We found out how to. So my big sister created the chair by making. She made that chair. And that was the first chair we made. And then Sammy found an improved way, kind of like Ford did, to make the chair faster and quicker than what Witter did.
My question is, when you talked about the scale, you said that you divided by 15. Why did you divide by 15? Whoever had
Because the map is, the paper was 15 inches? Yeah. And it was right for the room, so we had to make the paper just a little bit, the room just a little bit smaller, because we wouldn't use up the whole paper, so we just divided by 15.
So, yeah, we used this paper, and so we had to make the scale so that the room fit on the paper. And as you can see, this is only a certain width. So we could measure it as long as we wanted to this way, but we had to make sure that the short end of the room would fit on the board.
Okay, so welcome to the robot session 2012, and our students include Isaiah, Blake, Luca, Shaden, and Jimmy.
Walter.
And Walter, who's not here though. And me, Fiona. And Mr. Dave, and then we call our project Robot.
The goal. The goal of our project was to make a robot that could drive through an obstacle course, which basically meant from that piece of masking tape to the square on the wall. Not a very detailed obstacle course. We had to shoot that box. We had dart guns, but Dave forgot them. So as you can see, we made catapults. It was pretty fun. I really liked the catapult.
How we put the catapults together. Well, basically, I was going to put it on the side, but like it was not enough room, so I decided to put it on the top, so it would be a better fit. I had to figure it out myself because we didn't have any directions, so it was like basically it was hard.
Programming the robot, we had to hook it up to the computer and program it to go straight, left, right, or go backwards. We made changes by testing it and trying to get it to go to the top end.
Freshman period, I was in the class of origami, and so I learned that origami is a fun way of folding paper and learning math with it. And I have learned to make different shapes using different Sonobe units, such as cubes, pinwheels, and different house units. And so that's what we're going to show you today.
Pinwheels are also known as ninja stars. Where is the octagon in this figure? Here. We used 8 paper units to make this. Each piece of the pinwheel is a module and is also a parallelogram. A parallelogram is formed with 2 sets of parallel lines. Parallel lines are two lines side by side that never intersect.
I'm going to talk about angles, and these are the type of angles. A right angle is 90 degrees, obtuse angle is more than 90 degrees, and an acute angle is less than 90 degrees.
Okay, so I'm going to talk about the Sonobe units, and they were made by Mitsunobu Sonobe, and I'm going to show you how to make the unit. We have your open piece of paper, and we're going to fold it in half. There's your folded half. The second step is to fold it into fourths. So, into fourths. And now we're going to take the corners and going to make these small angles here. And here. And then we're going to make big ones like this. We'll make a parallelogram. And then we're going to take these and we're going to tuck them under the opposite side. And it will end up like this. And then the last step is to take this point and bring it up to right here. And on the other side. And that will be this. Now for the stellated octahedron, which will be this, there's one more fold that we do, and that's folding it in half, like this.
I'm going to show you how to put them together if you make enough Sonobe units to make a box. You take one of the corners and put it in these folds. Take another one and fold like this. Once it's like this, you need to put this up in there. Basically keep doing it
lunchbox like this.
Talk about bills and semi-bills, which are these. They're used to make different shapes, so they're basically kind of like Sonobe units. They're the base of different kinds of shapes.
You can make almost like a box or
with
a star, like a house, or a star.
So basically, as you can see here, you use the bills and you put them together, and then when you make two of them, of the put together bills, you stick them together and you fold it together to make a box like that. And then using that box, you can make different things like the house. As you can see, this is made out of 4 of these boxes, and the flower is made out of 6 of those. And then, so this is a bigger version of that flower. So as you can see, if you take it apart, it would be those boxes. So that's what semi-bills and bills are used to be.